Welcome friends, my name is Ranvir Abhay Sanjay, studying in B.Sc. second year from Adarsh College Hingoli. Today I am telling about theorem of geometric series. First we know about what is geometric series. Geometric series is a series in which ratio between two consecutive terms is constant. Now we see theorem of geometric series. Statement: the positive term of geometric series 1 plus r square plus r cube plus dash 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 converges for r less than 1 and diverges to plus infinity for r greater than and equal to 1. Here r is common ratio between two consecutive terms. Now we see proof. Proof is divided into three cases. Let's see case first. When r is less than 1 and greater than and equal to 0, let sequence Sn be a sequence of its partial sums so that Sn equal to 1 plus r square plus r cube plus dash 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 plus r raised to n minus 1. Friends, we have formula for finding sum of n terms of geometric series, which is given as Sn is equal to 1 minus r raised to n divided by 1 minus r, which then we can write as sum of n terms is equal to 1 minus r raised to n divided by 1 minus r, which is equal to 1 divided by 1 minus r minus r raised to n divided by 1 minus r, which is less than 1 divided by 1 minus r, so that sequence is bounded above. And we know that every positive term sequence which is bounded above is convergent, and hence the series is also converges. Now friends, we see case second. When r is equal to 1, then Sn is equal to n, so that sequence Sn is not bounded above, and hence the series diverges to plus infinity. Now friend, we see case third. When r is greater than 1, then every term of Sn after the first is greater than first, so that Sn is greater than n. Therefore, the sequence Sn is not bounded above, and consequently the given series diverges to plus infinity. Now friends, we see problem on geometric series. Problem first: show that the series 1 plus 1 divided by 2 factorial plus 1 divided by 3 factorial plus dash 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 is convergent. Answer: 1 plus 1 divided by 2 factorial plus 1 divided by 3 factorial plus dash 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 is a given series. Here first term is 1, second term is 1 divided by 2 factorial, which is equal to 1 divided by 4, which is less than 1 divided by 2. Third term is 1 divided by 3 factorial, which is equal to 1 divided by 6, which is less than 1 divided by 4, and 1 divided by 4 is equal to 1 divided by 2 square. Fourth term is 1 divided by 4 factorial, which is equal to 1 divided by 24, which is less than 1 divided by 8, and 1 divided by 8 is equal to 1 divided by 2 cube, and so on up to infinite terms. So friends, we get new series 1 plus 1 divided by 2 plus 1 divided by 2 square plus 1 divided by 2 cube plus dash dash dash. Now comparing these two series, we get relation 1 plus 1 divided by 2 factorial plus 1 divided by 3 factorial plus dash 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 is less than 1 plus 1 divided by 2 plus 1 divided by 2 square plus 1 divided by 2 cube plus dash dash dash. Here 1 plus 1 divided by 2 plus 1 divided by 2 square plus 1 divided by 2 cube plus dash 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 is geometric series. In this geometric series, r equal to 1 divided by 2, which is less than 1. And now and friends, we already seen that in positive term geometric series, when r is less than 1, then the given geometric series is convergent. Then the geometric series 1 plus 1 divided by 2 plus 1 divided by 2 square plus 1 divided by 2 cube plus dash 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 is is convergent, and hence by comparison test the given series is also convergent. Thank you friends for watching.